Hi, my name is Gayatri Menon, and this is my Lab 4 on circuits. The purpose of this lab was to measure the voltage, current, and how these vary with the capacitors and bulbs of different resistances in a circuit. We used the program from CU Boulder FET, which is an interactive Java program to help model this virtually. I was able to build a circuit and able to measure the voltage and current throughout the circuit using this program. Capacitors work by storing electrical energy. When charging, electrical energy is stored on the plates of the capacitor and will reduce the current in the circuit. However, when discharging, this electrical energy will again be released into the circuit and current will go up again. Looking at this circuit, I was able to predict that the current going through the circuit would be 0.02014 using the formula V is equal to IR. When I used the virtual lab, as you can see with the picture on the right, the voltage shown is 0.02, which would have been rounded up from 0.02041. Although not shown here, when I did switch the connection of the ammeters, I was able to read that the current was negative. When calculating the voltage in different parts of the circuit, I was able to see how the potential difference changed. The only two places where there was a significant potential difference was between A and B, which is where the battery charged the two batteries charge the rest of the circuit, between C and D, which is over one resistor, and between E and F, which is over the second resistor. As you can see, the potential difference as the resistance increases also increases. This is because the current would have stayed the same at 0.02014 amps. When added up, the total voltage around the circuit should add up to 3 volts, which is equivalent to the number of volts in the two batteries combined. This is because the circuit is in series and will have the same current everywhere, even if the other ammeter is removed. When adding the ammeter parallel to the 100 ohm resistor, I get a current of 0.06 amps. And as you can see from the figure at the bottom, I have completed the graph that shows the approximate potential difference compared to the position in the circuit. When looking at the RC circuit, you can see that when the capacitor and bulb are both in the circuit as the circuit is charging, the bulb becomes dimmer. However, as the capacitor charges, the current in the circuit will get smaller over time. When you remove the battery and close the circuit, the capacitor will start to discharge, which will cause the light to get bright again, till the current is all gone, so it will start dimming further. I was able to measure the time taken to discharge and charge a 200 millifarad capacitor compared with two bulbs, one of 20 ohms and one of 10 ohms. As you can see, the time taken to charge the 10 ohm bulb was a lot longer than the 20 ohm bulb. However, discharging the 20 ohm bulb was a lot longer than the 10 ohm bulb. This table shows my results when trying to measure the voltage of a discharging capacitor at different intervals throughout 20 seconds. I attempted to take the time every second, however I wasn't able to get it on the dot, and thus the varying times. You can see that as the time goes on, the voltage in the circuit starts to decrease at an exponential rate. However, when you take the log of this decrease, you are able to see that there is a linear pattern, as you can see in the graph. The slope of my linear line of best fit is 1 over RC. Thus, calculating the value of RC, I had to do 1 over negative 0.1293, which got me 7.734. However, I was able to calculate that the actual RC value is 6, which is relatively close to the value I calculated. Thank you.